In this video, we're going to look at direct proportion, okay? And we say that two quantities are in direct proportion if they increase or decrease at the same rate. And the ratio between the two quantities is always the same. So let's have a look at some examples. I'm sure that you agree with me that if I buy one chocolate bar, I have to pay $1.20. So if I want to buy two chocolate bars, the same chocolate bars, then I have to pay $2.40. And if I choose to pay 10 chocolate bars, I have to pay £12. So if the number of chocolate bars is multiplied by 2, then the amount of money I have to pay is also multiplied by 2. If the number of chocolate bars, okay, is multiplied by 10, then the amount of money also is multiplied by 10. So this is what I mean when I say that the two quantities increase at the same rate. So when one value is multiplied by 2, the other one is also multiplied by 2. If one is multiplied by 5, then the other one is multiplied by 5. If one is divided by 7, then the other one will also have to be divided by 7. Okay, this is what we mean when we say that they increase or decrease at the same rate. Okay, now this time we're going to look at how to solve some direct proportion problems using a slightly different method. Okay, and this is a little bit more advanced method that will allow us to solve problems that are a little bit more complex. We're going to use this type of statement. Okay, this reads that y is directly proportional to x. This can be also written this way: y is directly proportional to x, where k is constant. Okay, we're going to look at some of that type of statements in a bit more detail in a moment, but that's kind of what we're going to be using. Okay, you also should know that when it comes to representing direct proportion on a graph, it is a straight line that goes through the origin. Okay, it goes through the origin, so it goes through the point 0, 0. So let's have a look at some statements. Here are the most common statements involving direct proportion. Okay, so when we say that y is directly proportional to x, this can be written in this way. Okay, y is directly proportional to x. And remember that k is constant. Okay, next statement, y is directly proportional to the square of x. Okay, so y equals k x squared. Y is directly proportional to the cube of x. Y equals k x cubed. And y is directly proportional to the square root of x. Y equals k square root of x. I hope this is quite straightforward. Okay, so k is the constant of proportion, and we need to include that in our equations. Okay, let's have a look at some specific examples now to see how we can actually use it to calculate some values. This is our first example. M is directly proportional to h. If h is equal to 6, when m equals 2, find the formula connecting m and h. Okay, and this is what we mean. So first of all, I'm going to write down that statement. Okay, m is directly proportional to h. So m is directly proportional to h. And now I have those two values. Okay, I know that if h is 6, then m is 2. So I'm going to substitute those values. I'm going to put those values into my formula. Okay, so m is 2, and then h is 6. So now to find the value of k, okay, because this is what I want to find, okay, I need to divide both sides by 6, so the value of k is 1/3. Now I can put this value of k back into my equation. So I know that m equals k is 1/3, okay, h. And when you look at it, okay, 2 is 1/3, okay, of 6. Okay, so now using that, this is our formula, okay, connecting M and H. And now I can use this formula to find any other values. So for example, I can find H when M is equal to 5.5, okay? So M equals 5.5, I'm going to put this value into the formula, okay? So 5.5 equals a third H, okay? So now to find the value of H, I need to divide both sides by a third, and the answer is 16.5, okay? Or 16 and a half. Okay, now I've got the value of H, but I want to find the value of M. So again, I'm going to substitute the value of H into the formula. So that is M equals a third times 12. So M equals 4. Okay, and that's it. Let's have a look at another one. In this example, the values are given in a table, okay? So just be prepared that sometimes you may see a question in this form. So now in this case, B is directly proportional to the square of A. That is very important, and sometimes it's easy to forget about the square. Okay, so I'm going to write the statement. B is directly proportional to the square of A. Okay, B is directly proportional to the square of A. Now notice in my table I've got one pair, okay, of values. Now here I've got B missing and here I've got A missing. Okay, in this case here I've got both values, so I can use it to work out the value of K. I need to find that constant of proportion. So I'm going to substitute the values into my formula. So that is 14 equals K times 2 squared. Remember that you need to square A. 14 equals 4K. So to find the value of K, we need to divide both sides by 4, and that is 3.5. Now I can put the value of K into my formula. So that is B equals 3.5A squared. Okay, this is my formula, and now I can use this formula to find the missing values in my table. So first I'm going to try to find the value of B when I have A equal to 5. Okay, so B equals K times 5 squared. Okay, and remember that the value of K is 3.5 times 25, and the answer is 87.5. So the value here is 87.5. Then I can find this missing value here. So this time I'm given the value of B. So that is 61.74 equals K times A squared. Remember that the value of K is 3.5. Okay, now to find the value of A, first I have to divide both sides by 3.5. So A squared equals 17.64. And then now I have to square root both sides to find the value of A. Okay, so that is square root of 17.64, and the value of A is 4.2. Okay, 4.2. Okay, that's it. So we worked out the formula first, and then we used the formula with the value of K to work out the missing values. G varies directly with the square root of f. Okay, again, please remember about the square root of f, and then when G equals 20, f equals 25. Okay, and now we need to find the formula connecting G and f first. So I need to start with this statement. Okay, we say that G varies directly, and this is just another way of saying that it's directly proportional to the square root of f. Okay, and then when g is 20, then f is 25. Okay, square root of 25 is 5, so it's 5k. So the value of k is 4. So I can put this back into the equation. So g equals 4 square root f. This is the formula connecting g and f. Now I can use this formula to find the value of g when f is 81. So g equals 4 times square root of f, and f is 81. So g equals 4 times 9, g equals 36. Okay, and one more. In this question, I have all the values given in my table, but I need to decide whether they are in direct proportion or not. Remember that there will be indirect proportion if k is constant. Okay, so if, for example, I assume that d is directly proportional to t, okay, then to find k, I have to divide d by t. So let's have a look. I'm going to take the first pair, okay, and the distance is 8, the time is 10, okay, that's 0.8. Okay, I'm going to take another pair, 16 over 20, and that is also 0.8. Next pair, 24 over 30, that is also 0.8. And then 32 over 40, and that is also 0.8. So you can see that all of those values, okay, are 0.8. So that means that k is constant. Okay. So yes, they are in direct proportion because k is constant. Okay. Now, what is the relationship between s and t? Well, we already worked out the value of k, so that means d equals 0.8 t. Okay, this is the formula. Okay, so d equals 0.8 t, and then work out the distance traveled after 25 minutes. Okay, so d equals 0.8 times 25, which is 20. Okay, and that's it.